Now we're going to look at moles and molecules or atoms, and also some conversions between grams and this as well. So the first thing we're going to do, remember Avogadro's number is 6.02 times 10 to the 23. That's equivalent to atoms if you have a single element, or molecules if you have a compound. So we're going to use that conversion factor. So the first thing I'm going to do is I have my 2 moles. And it doesn't matter what this is because this is going to be the equivalent no matter the substance. I'll put my 1 mole down here, my 6.02 times 10 to the 23 up here. I'm going to use MC for molecules. And this will be 1.204 times 10 to the 24 molecules. And you would do the same for any of these others. So if we did this third one, we have 0.75 moles, 6.02 times 10 to the 23 on the top. To go to molecules was equivalent to 1 mole, so the mole units are going to cancel. And then now the rest is just plugging into your calculator. Remember, when you're doing this here, you're going to say 6.02, find your EE button, mash it for the times 10 part, put in 23, and then your equal sign. So you're going to get 4.515 times 10 to the 23 molecules. If we go back to moles from your molecules, so let's look at number 8, for example. You're still going to use the same conversion factor. I'm looking for moles, so I'm going to put that on the top. My conversion factor between it and molecules is the Avogadro's number, so I'm going to put that on the bottom. This would be molecules, and now the rest is plugging in your calculator. So again, to plug this in, I'd say 1.5 EE, or maybe EXP on your calculator, 20, then divide by 6.02 EE 23, equal sign. Now this one extended it out, so you may get this, or you can put it in scientific notation either way. Either answer would be correct. Now if we do a mixed problem like this one, you're going to find out how many grams there are in this many molecules. So like we did with the liters earlier, you're going to have to start off with your molecules, take it to moles because we know that's kind of like the intermediate step. We know that we can get this from using Avogadro's number, and then we'll go to grams by using the grams formula mass of our carbon dioxide. So we have a little bit more work to do on this one. Yes, a 2-step process. So we'll start off with the 1.5 times 10 to the 25 molecules of carbon dioxide. We know we can get that to moles because 6.02 times 10 to the 23 molecules of anything, in this case carbon dioxide, will be equivalent to a mole. And then we know we have 1 carbon at 12. We have 2 oxygens, each at 16. For a total gram formula mass of 44. So that 44 grams is equivalent, remember, to 1 mole of that substance. So we're going to take our, since we want to go to grams, we want to put our 44 grams on the top to our 1 mole down here. Moles of carbon dioxide will cancel. Molecules of carbon dioxide will cancel. You'll be left in grams of carbon dioxide. And now the rest is just putting it into your calculator. So you'd say your 1.5 times 10 to the 23, so use your EE times 25, divided by 6.02 EE 23, and then multiply that by 44, and you're going to get 1.096 times 10 to the 3, and that would be grams of CO2. So look at number 3. You have a sample of NH3, you have 75 liters. How many molecules? So this time you'll take your liters to moles, moles to molecules. So remember our conversion factor here is 22.4 liters is equal to a mole. So we'll start off with that one. The 22.4 needs to go on the bottom so that the liter units can cancel. And now you'll be in moles. And then from moles to molecules, if we're going to molecules, you want your molecules on top. So that's going to be the 6.02 times 10 to the 23. And my 1 mole here on the bottom. You can read that right there. So mole units are going to cancel there. So now when I'm doing my actual calculation, I would say 75 divided by 22.4 times 6.02, the EE23, and I'm going to get 2.02 times 10 to the 24 molecules of NH3. Now number 5 is a little different, so I'm going to run through that one real quick, and then this will give you some time to work on some of these others. But if you're looking for atoms in a molecule, then you basically, all you have to do is look at your formula. You know how many atoms are in this formula because we did this earlier. We've got 1 nitrogen, we have 2 oxygens for a total of 3 atoms in that 1 molecule. That's our conversion factor. So all I have to do is take my 1.3 times 10 to the 22 molecules, use this as a conversion factor. My 1 molecule of NO2 has 3 atoms total in it. And then all I got to do now is multiply this by 3. So it'll be 3.9 times 10 to the 22 atoms would be in that much of the NO2. So that one's a little different. So try number 7, which is on the next slide, and it's going to ask you to do something very similar to that.